Does the National Electric Code allow copper-clad aluminum? The short answer is yes. Beginning with the 2020 National Electric Code and the 2021 IRC, copper-clad aluminum is an approved method of installation. So let's get right into some of the specifics of the use and application and inspection and some opinions concerning copper-clad aluminum. Section 110.5 of the 2020 National Electric Code states conductors used to carry current shall be of copper, aluminum, or copper-clad aluminum, unless otherwise provided in this code. Additionally, Section 310.3 of the 2020 NEC states conductors in this article shall be of aluminum, copper-clad aluminum, or copper unless otherwise specified. This was a significant change in the 2020 National Electric Code and the 2021 IRC Section 3406.2. So let's discuss a few of the key facts about copper-clad aluminum, specifically these three. Number one, it is fully code approved and UL listed. It does require upsizing because aluminum conducts electricity different than copper. So copper-clad aluminum wire must usually be installed 2 AWG sizes larger than solid copper to carry the same amperage. That means more conductor in the walls and potentially deeper electrical boxes to handle the extra volumes. Number three, it looks like copper, but it behaves differently. The outer copper cladding makes it easy to mistake for solid copper at first glance. This is exactly where some problems can occur. So let's talk a little bit of copper-clad aluminum history. And this comes from the Copper-Weld website. Copper-Weld is probably the leading supplier of copper-clad aluminum in the United States. There is a misconception among many folks that this is a newly developed product, but copper-clad aluminum wiring has been around since the 1970s. If you think about it, we had a copper shortage and we had to try to come up with some ways to save copper, and this was one of them that was proposed. Unfortunately, there was a bit of a rush in this product being put out on the market, and because of that rush, there were problems found with the copper-clad aluminum that did not come through the initial testing and the science. So that led to a lot of problems. After 1977, copper prices began to decline, and solid copper wiring continued to be the most dominant product on the market. Now, CCA wire is a bimetal product. A thin layer of copper is bonded to the aluminum center core. Now, this is a different manufacturing process than you see with standard aluminum, which is more of an alloy. The copper coating on CCA is a minimum of 10% of the cross-sectional area of the solid conductors. But the aluminum center core is made from a series of AA8000 alloy, which is much stronger than what was used in the 1970s. Copper-clad aluminum conductors are subject to the ampacity requirements that apply for aluminum conductors, as well as the other provisions of the National Electric Code. So there are specific tables you need to go to when you use this product. The ampacities for conductors are determined in accordance with the 2020 NEC 310.14 and NEC tables 310.16 and 17 for ampacity values at rated temperatures. Separate columns in the tables are provided for copper versus copper-clad aluminum and aluminum conductors. For example, a typical 15-amp residential branch circuit would use 14 AWG copper, or 12 AWG copper-clad aluminum. Coordination with the overcurrent protection device for small conductors would be found in NEC 244D. Also, you need to see NEC 110.14C for conductor temperature limitations due to determination provisions of the code. So you have to do the math. The ampacity rating for a CCA used for branch circuits would be as follows. For 10 amp, you'd use a number 14, and that's a new provision that will appear in the next cycle of the code. Currently, where I'm at, we're in the 2020 NEC, about to go 2023. This new provision will probably be 2026. 15 amps is going to be number 12, 25 amps is number 10, And 35 amps would be a number 8. Although a number 10 is rated for 25 amps, 25 amp breakers or fuses cannot be used for a branch circuit supplying general use receptacles because the overcurrent protection device cannot exceed the rating of the receptacle. The same would apply to a dryer circuit. The receptacle is rated for 30 amps, so the breaker cannot exceed the 30 amp rating. So to reiterate this, in the 2021 IRC section 34061, the minimum requirements, you're going to see that the minimum size for conductors for feeders and branch circuits will be 14 AWG copper and 12 AWG aluminum or copper-clad aluminum. So that's the first thing you're going to see in new construction is you're going to see number 10 and number 12 run, where typically you see 14 and 12. And we're looking at the 2026 NEC. We're going to see a requirement now that says you can use 14 AWG copper-clad aluminum as an approved conductor for 10 amp branch circuits. So here's a question. Can copper-clad aluminum conductors be terminated to a switch, such as a general use snap switch or dimmer, circuit breakers, or other switching control devices? And then what about receptacles? Terminals 15 amp and 20 amp snap switches and receptacles are for use with copper and copper-clad aluminum conductors only, unless marked COALR, which then allows them to be used with aluminum conductors and copper-clad. Terminals of switches and receptacles rated 30 amperes and above are for use with copper conductors only, unless marked ALCU, which allows for use with aluminum, copper, and copper-clad aluminum conductors. These statements are supported by Section 404.15c and 406.3c of the 2020 NEC and UL Guide. So again, terminals for receptacles. Terminals of 15 and 20 amp receptacles not marked CO/ALR are for use with copper and copper-clad aluminum conductors only. Terminals marked COALR are for use with aluminum, copper, and copper-clad. So that's the big difference. Specifically, the way everything's looking at right now, if it's rated for copper, then the copper-clad is also going to be permitted. Question always comes up about wire nuts. Section 110.14 of the 2020 NEC has revised to clarify that copper and copper-clad aluminum are not considered dissimilar metals in a terminal or splicing connector where physical contact occurs. So what type of connectors are certified or listed for terminating copper-clad aluminum conductors? So if we look at a white paper from UL, we're going to get the answer. It says, even though they are constructed differently, copper conductors and copper-clad aluminum conductors are not considered dissimilar metals for conductor terminations because copper is used for the outside cladding of both of them. Copper conductors are solid copper, and copper-clad aluminum conductors have an aluminum core covered by copper. The surface of each type of conductor is copper, which is the important issue for terminations. However, copper-clad aluminum conductors have an aluminum core, so they have the same ampacity as aluminum conductors. It is incorrect to assume that wire connectors suitable for copper-only CU can be used to terminate copper-clad aluminum conductors. And copper weld makes a whole host of different colors and everything else of both twist and other types of wire connectors. Wire connectors used to connect copper-clad aluminum to copper conductors have to be rated for copper and aluminum connections or rated for copper to aluminum intermixed and in direct physical contact. So it's suggested on the packaging for your connectors that you look at their listings. This is a small chart here that gives you a little bit of information, but it's always well to look at the manufacturer's installation instructions and the packaging requirement. Now here's a little something from the copper weld side again. It says turn off the power, select the appropriate wires. Strip wires to recommended lengths. One of the things you need to keep in mind though is when you're stripping out your copper-clad aluminum, you don't want to damage the copper outer core and then expose aluminum, now do you? So that's a concern that I've always had. And again, copper-clad aluminum is treated like copper, so special wire nuts, the purple wire nuts with the coatings and all that, it's not required. You don't have to use inhibitor on the terminal locations. Now this is from the Schneider Electric website, and products change all the time, so I would suggest you go and take a look at the most up-to-date information, but this is what we have so far in 2026. Schneider Electric wiring devices, the X series, currently indicate on the body of the product and on the documentation that comes with it that they support copper wire only. Copper-clad aluminum conductors are considered similar to copper, brass, or zinc-plated steel in that similar metals can be terminated together without oxide inhibitors in dry locations. Therefore, Schneider Electric supports copper-clad aluminum cable being used with the side and or back terminals of the 15 amp and 20 amp wiring devices marked copper only under the following ampacity guidelines. Number 12 for CCA, number 10 for CCA for 20 amps. To continue from the Schneider Electric site, it says that our push-in terminals on 15 amp devices shall only be used with 14 AWG solid copper wire. Neither CCA or stranded can be used. So what we see is a lot of people are taking 14 gauge copper and doing the backstab, and then they're making a little pigtail, and then going to the CCA from there with a wire nut, which just takes up more room. But it's one method. So another question that came in is what wiring methods are permitted to utilize copper-clad aluminum conductors? And so part one of this, individual conductors, as noted, Section 310.3b of the 2020 NEC permits copper-clad aluminum to be utilized for individual conductors. As an example, thermoplastic insulated copper-clad aluminum conductors are listed in accordance with UL 83 in sizes from 12 AWG through 1000 kcml. Individual conductors for general wiring are required to be used as part of the recognized NEC Chapter 3 wiring methods for raceways, cables, and cable trays. All right, to continue on, number 2, metal-clad cable, type MC, section 330.104 of the 2020 NEC permits copper-clad aluminum circuit and equipment grounding conductors to be utilized in type MC cables in sizes not smaller than number 12 AWG for control and signal conductors. Let's go to number 3. Non-metallic sheath cable, type NM. Section 334.104 of the 2020 NEC permits copper-clad aluminum conductors to be utilized in type NM Romex cable in size 12 through 2 AWG. This includes circuit, equipment, grounding, control, and signal conductors. Type NM cable is required to be listed to the requirements that we find in UL 719. Moving on to number 4, power and control tray cable type TC is covered here in number 4. Number 5, underground feeder and branch circuit cable, section 340.104 of the 2020 NEC permits copper-clad aluminum to be utilized in type UF cable in sizes 12 through 40. I want to touch a little bit here, and we'll go more in depth in another video, but I want to talk about the pigtails and backstabbing, all right? So copper pigtail leads may be used with aluminum or copper-clad aluminum supply wire in dry locations if the following. Number 1, the splicing devices are certified for use in joining copper to aluminum. There is sufficient wiring space, and the means provided for connecting the wiring system are acceptable for the wire size. For a backstab connection, you just push the strip wire into a hole in the back of a receptacle or switch. This is less secure than attaching the wires to the screw terminals. I myself am not a fan of this method. It's a quick method, and it's got to be number 14 for most of these devices. But again, it is permitted by the code. Remember, the code is a minimum. In case you didn't pick up on it, I'm not a fan of backstabbing. So here's my 2 cents worth. Backstabbing is a way to connect electrical outlets or switches. It involves putting wires into small holes at the back of their devices. Now, this method is different from securing the wire with the screws, and it was very common in the 70s and 80s, and it's a shortcut to save time. Today, professional electricians typically avoid this practice due to potential hazards. Let's talk about a few key takeaways. Backstabbing involves inserting the wires into the back of the outlets instead of securing them with the screw. And though it saves time, this method can lead to a serious life safety hazard like electrical fires. Many homes built in the 70s and 80s may still have backstabbed outlets. A qualified electrician can identify and correct backstabbed outlets to ensure your safety, and I highly recommend it if you have an older home. Now, I guess the good folks at UL took some DEI lessons and they decided that people don't like that term backstabbing, which is a negative term, and I agree with it because it's a negative practice, and that's my opinion. So they say screwless terminal connections of the conductor push-in type, also known as push-in terminals, are restricted to 15-amp branch circuits and for connection with 14 AWG solid copper wire only. Period. End of subject. Backstabbed outlets often lead to loose wire connections. Loose wire connections lead to fires. Over time, these loose wire connections cause serious issues, including electrical fires, power interruptions, wires are shifting around, and outlet damage, heat buildup that may melt or damage a single outlet. Again, I'm not a fan of backstabbing any outlet at any time under any circumstance. I have another video out there on my 2 cents with CCA, and you're more than welcome to look at it. We're just going to touch on a few things. The IRC and the NEC do permit copper-clad aluminum, and it is a choice that you have if you're in the market. So there's always the concern that came up from the 1970s, all right? So the problem is that CCA expands and contracts like aluminum, not copper, or that's what's always been kind of presented as the problem. And in the past, there was a huge problem, and that was exposed in the 1970s with aluminum wire used for 15 or 20 amp receptacles, which had been hastily rated ALCU. The product just was not ready for that rating. The problem referred to was a function of the widespread use of aluminum 6061 alloy in electrical products. During that time, modern aluminum is classified differently and has less coefficient of thermal expansion. So again, here's my 2 cents worth. There are some issues I think out there that homeowners and such ought to be aware of, builders, when they use CCA on these residential structures. You know, because copper-clad looks like copper, most people will make mistakes thinking they're tying to a copper conductor if they're doing kind of renovation work or anything in the future. And sometimes an inspector or electrician who thinks a number 12 might be able to allow a 20 amp breaker and to get excited when they see the breaker is too small, and they'll go swapping one out and putting in a bigger one. They allow the conductors to overheat because they assumed it was a copper conductor, not copper clad. One of the things too I always concern about is when you're making your terminations, if you strip the outer part of that copper and exposing that aluminum, then what kind of dangers have you exposed everything to? And then you got to worry about incompatible devices. Those are another issue. So there are several issues with copper-clad aluminum that I have some concern about, and I know the manufacturers, kind of, downplay these things, but these are my concerns, and they're mine. The code book does not have my name on it. I'm not on any of the panels, right? So the code is the code, and as long as you install by the code, you met it. But for me, if I was an AHJ and I could kind of flex my muscle a little bit until I'm challenged and somebody changes my mind, otherwise, I'd make some of the following suggestions. I would say that all terminals and terminations should be torqued with a certified torque tool per the specifications. And I think the city or the jurisdiction, municipality, whatever, should confirm that. Not with their own equipment, but to look at what's been used. The torque specifications are very, very critical. I'm a firm believer that the majority of problems occur at the terminations. So therefore, proper torquing is in the code, and I think the AHJ has a legitimate right to make sure it's been done. So some of the things that are in the code in Article 110.5 and 310.3 is copper-clad aluminum wiring for branch circuits must meet the requirements of these sections. Copper-clad conductors are subject to ampacity requirements, so they have to be checked. The installation of copper-clad conductors for use as branch circuits must meet the requirements of 310.14. So it's well to review these in the field and also in the office before going out into the field. Again, we're looking at code again, right? Uses not permitted. NM, NMC, and NB. Cables should not be installed or subject to damp, wet locations such as any or all exterior outlets. So it has to meet all these requirements. Per UL, screwless termination connectors of the conductor push-in type are restricted to 15-amp branch circuits and are for connections with 14 AWG solid wire only. They are not intended for use with aluminum or copper-clad wire. So keep that in mind. Could be, but probably not in the code. Again, this is my 2 cents worth, right? So I think when we're dealing with copper-clad aluminum in residential construction, we should have some restrictions on a few things. 12.2 should be no more than 10 outlets per circuit rated at 15 amps. 10.2 should have no more than 14 outlets per circuit rated at 25 amps. And number 8 or larger should meet the ampacity load requirements of the equipment being served. So these things should be checked. And getting back on the subject of terminations, it's imperative not to cause any surface damage to the conductors. If damage is found upon inspecting the termination, it should be redone and get rid of the damaged wire. It's not recommended to pre-twist copper-clad conductors when using twist-on type splice connectors. If pre-twist is done, make sure to perform it in a way not to cause surface damage. Wire connectors that are used to connect copper-clad aluminum to copper conductors should be rated and identified for their use. Devices such as snap switches, receptacles, and GFCIs are required to be listed and labeled and terminated for use with copper-clad aluminum conductors. And this product information should be made available on the site. Please go to the link that you'll see for code and commentary on copper-clad aluminum also. And like, share, and subscribe to this channel. We appreciate your support. Have a great day.